This is one view. I'm sure everybody has seen it. This is Nexus dashboard one view. And I hope you guys know we have a Nexus dashboard fabric controller one view as well. We have an NDFC one view as well. That is only for SAN. If not, yeah, let's go through it. So if you look at this, these are not just different sites, they're actually managed by different Nexus dashboard clusters, right? ND2, ND3, ND4, right? Nothing surprising here. But if I go to my ND, now I'm in NDFC. NDFC doesn't know, and hopefully it doesn't know that there's some called ND there. You see there's something called one view here, a new breadcrumb. It wasn't there before. If I can click here, it shows me everything that is being managed by different Nexus dashboard clusters. So ND one view is about the ND's itself, the infrastructure health of ND. NDFC one view is about the SAN fabric, right? This is what customers want, right? What's happening across your globe? Like, you know, this is something brand new that happened in last release 12.1.1. And not just that, the beauty is that you can actually hop onto any switch. Let's say you want to create, like, say you want to no shutdown an interface on a switch. You can actually hop from this NDFC to that NDFC without relogin. It's SSO enabled throughout. Okay, but I'll probably go there because, yeah, we should be focusing on SAN analytics, right? So you see there are multiple of them and you can jump from here and just select that. Yeah, just so that you guys know that. Previously, DCNM used to have this federation mode, if that rings a bell. I think it was nice, but I don't know. No, I didn't come across a lot many customers using it. It needed an external Oracle database. So that was one problem. It was quite pricey. Also, you can't really have a global view out of it because you can't have a database sitting in, like, let's say, North America and like your DCNM deployed in Europe. It's going to make it quite slow. We kind of resolve those problems with this because the data still sits at every ND cluster, but what we see at NDFC1 is just the presentation layer of it. Okay, but anyway, let's go to SAN Insights. Okay, so essentially this is like an overview of everything that's happening in the environment. Obviously, we get to summary the number of flows and everything. If you think about, it's not just a number like 1531 is the number of ITL flows that really stands for the initiator, target, and LUN flow. It's not just a number, but actually there's some kind of color coding in it. It tells me that around 314 flows show a deviation of 1 to 15%. And if you think about how exactly SAN Insights is calculating is, it's receiving all these flows. And as I said, as of this release, we support 500,000 flows here. So as NDFC receives 500,000 flows, it starts making a baseline of the completion time values or the ECT values for all these flows. And then it keeps on learning it for 7 days. After that, every hour, it calculates the hourly average value to the 7-day average values. And if those values differ by 15% or more than 15% based on these buckets that you see here, those flows are color coded accordingly. Right? So all this advanced analytics happen by itself. A user need not do anything about that. Right? And I'm not making a claim that it's the perfect algorithm that we have came up with, but it's better than having nothing. It's better than finding few flows out of those 500,000 flows, right? And at least what it does, it helps us to make a baseline that, hey, you know what, like yesterday, this red was really small. Today, it's small too, but if tomorrow this red becomes like fairly big, if this number 46, it goes to 460, that's something I need to worry about. I think one of the examples that I was using on the slides is something like you have the host here, so you can actually sort them down. Hey, you want to find out, hey, where is the slowest host, right? And by the way, I'm not going to repeat everything. Like there's so many recorded videos and there's some, demos out there. But something like, find out, let's say, where is the slowest host? You just find the answer really fast in a single click. Then you know, okay, this particular server is taking 1.5 millisecond to complete write IO transactions. And by the way, this is the average value of 24 hours. I don't like that. 24 hours is too long. But anyway, I can click on this, right? So first of all, I found the answer. I found which server, and then I click here. And look, there's a very interesting pattern. If you look at the pattern, um, well, it looks like let's start in the morning, right? So it looks like 5 a.m. There was a spike. The spike is quite a big spike from 1.4 1.5 millisecond, it spikes to 2.6. Then it comes to the same value. Then it again spikes, what, an hour, 20 minutes later? Then goes further. Okay, this is an hour and 15 minutes further. So it looks like there's some kind of spike, there's some kind of increase in the write IO completion time values that happens every hour and 20 minutes or maybe an hour and 15 minutes. So if let's say somebody from the application team, the application that's hosted on this particular server, B204, complains about it and they say that there's some time pattern to it, we exactly know why that application is affected. It's because of the storage access issue, because we clearly see it. Right? Now, next level, if you want to find out, okay, storage access is slow. Why is it slow? We don't know that yet. So we bring in more metrics like data access latency. You know what? For the sake of simplicity, because we're looking at write IO operations, let's get rid of, or at least remove the focus from read IO operations, and let's look at write. So now the black line here, the line on the top, shows how long is the total time taken to complete write IO operation. The orange line, the line at the bottom, it shows how long is spent within storage array. And look, the storage arrays are really fast. It's like less than 70 microseconds response time. Not really response time, not the right wording, but the access latency time. And even if there's a spike, there's a small jump in the data access latency value, but not something, I would be worried about. So what does it tell me at this time? It tells me I know where the problem is, I know when the problem happens, and I know storage access is slow, but I'm not going to worry about storage arrays. So probably I'm going to worry about host on the network. Okay. Now today, we are not bringing, or we don't have the slow rain metrics on this graph itself. That's something coming quite soon. But today, if you want to figure that out, so let's just kill this here, and there's a slow rain analysis. And I'm not sure whether I can show you the graphs of that because I was running into some kind of bug and the graphs won't plot. But you can go here, and there's a congestion analysis that all of our customers must schedule for daily for 24 hours. This is something we want to enable it by default in the coming releases, but today, tell all your customers to enable it or to run it in an always-on fashion. There's no performance side effect to it, their switches, right? We have powerful CPUs on the switches. They don't have to worry about that. Once they schedule it, all the data would be sitting here for them to analyze later, because they should have the data collected before the problem happens, not after the problem happens. And then they click on here, and something like, now what did I do? Okay, you click here, and obviously you get to see topology. You can actually click here, figure out, okay, looks like this particular port is couldn't like send for almost 60 seconds because of lack of DXB2B credits. Yeah, okay, and the graph popped. Okay, this is the bug I was talking about. But you see this, I can figure out, and well, okay, I see some kind of pattern here. So this happened around like 8 p.m. and this happened like an hour, 16 minutes later. And this one happens an hour, another 16 minutes later. Looks like a very similar frequency. So this is indirectly how I would correlate SAN congestion to slower response times. Like I have to do this manually, but the data is there, and this is how you can correlate. And by the way, somebody asked me, like, yes, when I did the demo, like somebody asked me, hey, how did you know that storage port is connected to that particular server? I know by looking at the other screens, not here, because if I go here, SAN Insights, remember we're looking at B204. If you go on monitor metrics, right, this is another way of getting inside the details. By the way, this screen, just to explain it, it gives a cumulative performance of the host, as if the operating system measures what is the throughput of B204 server, it's going to be 51 megabytes per second of read throughput and 102 megabytes per second of write throughput. But this screen doesn't tell us what is the performance per path. Okay, like if there are multiple paths to the storage array, I don't know how much read and write going on every path. So that drill down is available at the next level. With the topology view, automatically built, and a breakdown of every path here. And then this is what I was showing when I was doing that congestion analysis, that I know this particular server is talking to that particular storage array, and this storage array was causing congestion in the SAN. Right, this is the storage port that I picked and clicked on the graph, and there's a pattern that happened every hour, 16 minutes. That kind of matched with what we saw on the, completion time spikes, ECT spikes for B204 host. Okay, so hopefully it's making sense, right? How we can use ECT values to figure out the overall performance degradation at the storage layer. And when there is ECT spike, how we can use other metrics to drill down further and pinpoint really fast. And we don't have host response latency today within NDFC, but once we have that, we can actually pinpoint to the host itself directly. Right now, if you notice, I took an indirect approach because I realized there are three places that can slow down: a host, a network, or storage array. It's not the storage array, so I'm left with host and network, and then looks like I saw some kind of congestion within the network, so I'm going to focus there. But with host response latency, you can be, quite specific. Okay, the other pieces which is kind of new, which is anomalies. So look, I mean, NDFC today can receive, and the certified number is 500,000 flows. And if somebody wants to know, which flow has a problem, finding that is quite a challenging task. So for that, we have these anomalies. The way you would set it up, go under operation, there's event analytics. And as you can see, there are already some alarms raised here. Let me just try to read this one, the first one here, with the ID 6930. If I try to read that, it tells me this initiator, by the way, this is the device alias of the initiator, then this target port, and then I have a LUN value too. I can actually use the LUN value to go to vCenter and figure out which data store it's being used to create and what are the virtual disks that are being carved out of that data store, and figure out the VMs from there. As I said, it's a manual step, but it's much better than not even having that information. In the future, yeah, we're going to make it automated so that you click here and figure out which VM it is. But anyway, so we have the initiator, target, and LUN value. We also have the switch that detected this and the port on which this problem was detected. And it was detected, wow, at August 4. That means right now, looks like 12. Wow, it's like, what, an hour, 30 minutes earlier, West Coast timing. And looks like there's a policy that created the anomaly. So if I click here, let me try to read. It says whenever the average write completion time, average write ECT is more than 2 milliseconds, create an anomaly. Right. So yeah, that's how detected. Now, how you would create these policies, something like you create alarm policies and actions, you create new alarm policies, go under SAN Insights anomaly policy, and then you can say maybe, read ECT 8 MS. Okay, and then capture time. So capture time tells us once a problem detected, how long do you want to keep on storing data for that flow after the problem's detected. So let's say we detect an anomaly at noon. Then if I select 6 hour, the the data points at 30-second granularity would be stored for that flow until 6 p.m. Otherwise, by default, we store within NDFC SAN insight at a 5-minute granularity. Only if the anomalies are detected, we fall back to 30 seconds. Okay, so that is capture time. Retention time is once an anomaly is detected and the data is captured for 6 hours, how long do you want to retain the data? So I want to retain that for 14 days. Then analysis level. Should I be analyzing every 5-minute values or should I be waiting for an hour? It depends on what the metric is. If there's an error, if there's an abort, if there's a reject, uh, I want to know about it as soon as possible. But let's say if there's a spike in completion time value, if there's a spike in ECT, I mean, yeah, I don't want to get worried about every 5 minutes. It's too much noise, right? So I want to make sure if there's a spike, it's a sustained spike. Okay, so I would go with hourly, right? That's what makes more sense to me. And then I think 8 millisecond, if I'm going to create a policy for 8 millisecond, that may be a major problem. Or yeah, this is subjective, right? Everybody can define their own. Okay. All right, let's add a rule here. So obviously there are a lot of metrics here, but I would go with read ECT. And I'm saying anytime read ECT goes more than what? Now, obviously I started with saying 8 millisecond, but who can predict what ECT value is really bad? Like finding the answer of this basic question that how bad is really bad. I think that's quite an activity. A lot of customers struggle very hard for that, right? So for that reason, if somebody doesn't know, let's say there are some newer members on the team that's still trying to get a hang of it, they can go with this baseline value here that we have ready-made. Okay, so this is one way to create a policy. The other way is where I started from. Just select custom value and put 8 here and create this policy. So anytime any flow out of those 500,000 flows take longer than 8 milliseconds to complete rediode transactions and keep on doing that for an hour, then that would be that flow would be tagged as an anomaly, and that would show up here under event analytics as alarms, and it will also show up under SAN insights right here under these alarms. And obviously you can send them by email. You saw that option while creating an anomaly, right? So all those options are there.